So hello guys, today we will be studying the bubble sort algorithm in Python. Let's try to understand what is a bubble sort first of all, and then we will get and write the code for that. So suppose you have an array and it's given in front of you and you want to sort it. So there are various sorting algorithms, and in comparison to that, there is one today we'll be discussing is bubble sort. What does it means and how we will implement it, will go step by step. It works on the principle like we swap the adjacent pairs if the array adjacent elements are not in the correct place. What does that mean? Suppose 24, 5, 6, 8, 19, 23, 1 and 2. This is our array. Now we will check adjacent pairs. Are they at the correct place in a sorted fashion if I want to do in the increasing fashion. Now 24 and 5 are not in the correct fashion because 5 should come before 23, 24 as we are increasing in the sorted order. So they should swap. So what we will do, we will check every consecutive pair of elements. So see 24 and 6 still they are not same. So basically we will swap them again. It should be 6 and it should be 24. Are they now at the correct place? 24 and 8? No, still not now because 24 is still greater than 8. So we'll move to 8 and 24. Are they now at the same place? No, not it yet. Still, basically 19 will go here and 24 will go here. Now we will compare 24 and 23. Still, they are not at the correct place. So we will swap them again. So what we are doing in this algorithm is we are just swapping whenever we are not in the correct place. Then the elements are not in the correct place. Now at the end, it it reaches 12 and 24. What we realize is here is the maximum element reaches at the last position, reaches at the last position after one loop completes. After one loop completes. So basically what we observe, see, we have to observe things in this algorithm. We are swapping the consecutive elements if they are not in the correct place. Now we will do it for n times because this we have placed it the correct place. Now we will again start the loop and start comparing. Are 5 and 6 on the correct place? Yes, they are. 6 or 8 are the correct place? Yes, they are. 8 to 19 are at the correct place? Yes, they are. 19 and 23? Yes, they are. But 23 and 12 is not in the correct place. We will swap them out and it would be 12 and 23. So it is fine. Now it is. Now we will again start from the starting. The 5 or 6 are in the correct place. Yes, 6 and 8 are done. 8 or 19 are done. 12 or 19 are not there. So we'll swap it again. And it should be 12 and 19. And now if you observe the array is sorted and we just return when the array becomes sorted, I will tell you the whole procedure. This is our sorted array. Now let's try to jump on the code and how we will implement it. And I will discuss it and compare with other algorithm. Let's try to jump off to VS Code. So basically, let's try to create a new file. 2.py. What we will doing is we will creating a function known as bubble sort, and we are taking as an array as an input. So I am just taking an array as an input. Let's try to take the length, store the length in n. N is equals to length length of ARR. We just taken an input of length of ARR. Now we will iterate on all complete array. I told you that I will be iterating for n times. So basically, I in range n. We are iterating for n times because 0 to n minus 1. And now we will be swapping the adjacent element in a one loop. What I will do, we will again iterate for j in range. Now it's a very crucial point till where we should iterate. Ideally, we should iterate till again n. It should not been a problem, but you try to observe after each iteration the maximum element reaches at the end. So basically, after each iteration, we just need to iterate till first iteration we iterate complete list. The second iteration we will be iterating from here, and the third iteration till here. Why? Because the right part is already sorted. This one is already sorted. Why we need to compare that? We need not to compare that. So to optimize it further, what we will do, we will just iterate till n minus 1 minus I. Let's try to understand this as well. Now basically we will have here. Now how will we ensure that there's a wrong pair? So we will check if ARR of j plus 1 is less than ARR of j. That means they are not at the correct place. So we will try to swap them. So basically we will to swap them, just we are defining an temporary variable which is stored ARR of j plus 1, and now we are assigning ARR of just a simple code how to swap an element using a temporary variable. So basically we just swap them and then we are just setting ARR of j is equal to temp. Now basically this is our code, and now the array should be sorted enough. Yes. And now what we should do, this is done, this is done. Let's try to run this code and check if it is working fine or not. So, oh, sorry. So this is, I think, fine. Let's try to test a sample example. So basically this is our array. Now let's try to print the array. So firstly, let's try to declare an array. Array equals to whatever we defined there in our example, or we just take a random array 3, 4, 1, and 5. Okay, let's try to sort it. We just call the bubble sort function. We just call the bubble sort function ARR, and we'll just call the print function, and we just check the output. Let's try to check it out if it's working fine. So yes, it is perfectly working fine. Let me just try to show you clear. So yeah, so our array is working fine. Let's try to take this code and try to understand each step in bit detail. So basically, this is our code. So basically, this is our code. Basically, this is our code, and let's try to understand each step. So what we have done here, we have defined a function def as bubble sort, which is taking an input length ARR. And now we are iterating n times. Because why we are iterating n times? Because we already know, because there are n elements in the array, and to reach every element at the correct place, we need to iterate for n times. And then we are iterating for j in range n minus 1 minus I. Why we are this range is very important. Because you try to see, let's try to take an example again, like 1, 5, 3, 2, and we need to sort it. Suppose I am sorting it, and after the first iteration, what will you do? 3 and 5 will be swapped. 3, 5, and 2, and then 2 or 5 also be swapped. So basically, finally, after one ith loop, when I got incremented, it will be 1, 3, 2, 5. The 5 is reaches the end position. Now I don't need to iterate till here. I need to iterate till here. This is our logic. Yes, we need to iterate till here. So now I will iterate till here only. Let's suppose 1, 3, 2. So basically 1 and 3 are correct, but 2 or 3 are not at the correct place. So we'll swap them off. So basically 2 and 3. Now I need not to come iterate till end position till here. I should need to iterate till here. That's why I use n minus 1 minus I to optimize our code. Now let's try to understand what is the time complexity of the solution. The time complexity of the solution is, we can observe, as this loop runs for n times and this loop is run for n minus I times. So basically the time complexity, I can roughly say it's O of n square, or in exact terms, I should say it's n into n plus 1 by 2, but it's roughly n square. So we have observed this time complexity. Can we do it better? Can we reduce in some best case? This is the worst case time complexity. So worst case time complexity. So let's try to observe things. Can we do it better? Now, suppose I just give you an example. Now, suppose I give you a sorted array 1, 2, 3, 4, 5. When you it is already sorted, so why you are taking O of n square to check that? Can we do it in O of n and tell the array is already sorted? You need not to go further. Array is already sorted. So you not need not to go further. That is very important. So what we will do, we'll use a check variable is, does we swap at in one iteration. If we do not swap Like that means the array got sorted. We didn't find any swap. We didn't find a wrong pair. Let's try to implement in the code. So what we will do in in the jth loop, we just swap variable and we will check it to false. Initially, it is false. And now, if we eventually swap, we just make it true. So that in this iteration, we should not break. But if, or should we say, after the end of the loop, if not swap, we should break the code. Yep, if this true or not. Okay, so we should initialize this swap variable here before the for loop. So yeah, so we just initialize the for loop variable. Yeah, I think it should be pretty much fine. Yeah, so we got the code. This is how we optimize our code further. Now our optimized code is like this. We got like, let me just copy for you. Let me just copy the optimized code for you. And so in the best case, now this code will run for O of n only. This code will run for O of n only in the best case, because whenever the array got sorted, whenever the array got get sorted completely, it breaks. It breaks. So basically, this is one of the basic and beginner algorithm to sort an array. We can say its best step time complexity is O of n, and its worst case time complexity is O of n square. We generally use in the smaller inputs because it is easier to implement and it's easier to understand rather than the complex merge sort and quick sort algorithms. Let's try to brief it out what we have discussed in this video. So basically, we started with the bubble sort algorithm. What it was, we just tried the principle that it pushes the maximum at the last position and it's sort in that fashion, and it works on the adjacent swapping principle. So basically what we have done, we have just write the code for it. We just define a bubble sort function, and then we are iterating for n times, and in the jth loop we are iterating for n 1 minus I times, and we are just checking that ARR of j plus 1, the adjacent element, the next element, is it smaller? If it is smaller, we just need to swap the element. So what we done, we just swap the elements. So yeah, ARR is equals to this. We checked it out and we just observed the worst case, and the average case time complexity is O of n square. Can we improve on that? So we just saw that you can use a swap variable, because it will tell you that in the whole jth iteration, no swap has been occurred. What does mean? It means it is already sorted. Yes, it is already sorted. So you don't need to go further. You can just break it out. So, and the best case complexity become O of n. So yeah, that's all from my side. If you have any doubts, feel free to ask. Thank you.